Something out there is holding our solar system at an angle. We have never seen it, never photographed it, never given it a name in any textbook. But in August of 2025, Amir Siraj and two colleagues at Princeton University measured the orbits of 154 icy bodies beyond Neptune and found a 15-degree tilt that has no business existing, a warp that should have been smoothed flat hundreds of millions of years ago and was not. Something is maintaining it right now, closer to us than the furthest spacecraft we have ever launched. This is the story of what the mathematics says is out there. The outer solar system is supposed to be flat. Not perfectly flat. Nothing in nature is perfectly anything. But flat in the way a record on a turntable is flat. The planets orbit in a shared plane, tipped from one another by only a few degrees. And far beyond Neptune, the debris left over from building those planets should lie in that same plane, because that is where the material was when the solar system finished assembling itself. For most of the region we can measure, that is exactly what we find. But in August of 2025, 3 researchers at Princeton University published a measurement of that disk that does not agree. Out past Neptune, in a specific band of distance, the record is bent. The average plane of the icy bodies there is tipped away from the plane of the planets by roughly 15 degrees. That number sounds small. 15 degrees is a shrug in most contexts. But a 15-degree misalignment across an entire population of objects is not a shrug. It is a fingerprint. Something has to be pressing on that region, and it has to still be pressing right now. Or the tilt would have been erased long before humans existed. We have looked out there. We have found nothing. And the mathematics says that is exactly what we should expect. Something is bending the edge of our solar system. And the 2 leading explanations for it are both stranger than a simple missing planet. This is not a new method. It is the oldest trick in planetary astronomy, and it has an uneven record. In 1781, an English musician turned astronomer named William Herschel was sweeping the sky with a telescope he had built himself, hunting comets. On the 13th of March, he found something that moved like a comet but refused to behave like one. No tail, no brightening, just a small disk creeping against the fixed stars, orbiting the sun on a wide, patient path. It was a planet, the first ever discovered, rather than simply known. It became Uranus, and then Uranus began to misbehave. Its position drifted from where Newton's laws said it should be. The discrepancy was tiny, the width of a coin seen from several miles away. But it was persistent, and it grew. Either gravity was wrong, or something unseen was pulling. A French mathematician named Urbain Le Verrier assumed gravity was fine and the solar system was incomplete. Working with paper and logarithm tables, he inverted the problem. Instead of predicting a planet's motion from its position, he calculated a planet's position from someone else's motion. He sent the coordinate to the Berlin Observatory. On the night of the 23rd of September, 1846, Johann Gottfried Galle pointed a telescope at that coordinate and found Neptune within about 1 degree of the predicted spot. A planet had been discovered by arithmetic before anyone laid eyes on it. That success is why this method carries weight. But remember how it failed. Le Verrier, emboldened, applied the same reasoning to a wobble in Mercury's orbit and predicted a planet he named Vulcan. Astronomers searched for decades. Vulcan does not exist. Mercury's anomaly was not a missing planet, but a missing theory, and Einstein supplied it in 1915. The tool works. It also lies. The question is which one it is doing this time. Past Neptune, beginning around 30 astronomical units from the Sun, 30 times the distance from the Earth to the Sun, the Kuiper Belt begins. It is not a belt in any tidy sense. It is a broad, sparse population of icy bodies, dwarf planets, and fragments that never got assembled into anything larger. kept in cold storage for 4.5 billion years. Because those objects are leftovers, they should still lie where the leftovers were left. Astronomers define the reference surface precisely. It is called the invariable plane, the plane perpendicular to the total spin of the solar system, which in practice means the plane set mostly by Jupiter, because Jupiter carries the overwhelming majority of the angular momentum. Every relaxed population of bodies orbiting the Sun should average out to it. Individual objects can be tipped, sometimes severely, but average hundreds together and the tilts should cancel. That prediction falls out of the same mathematics that lands spacecraft on comets. And for 2 of the 3 regions the Princeton team examined, it holds exactly. This is not the first time someone has claimed the Kuiper Belt is bent. In 2017, Catherine Volk and Renu Malhotra at the University of Arizona published a paper titled The Curiously Warped Mean Plane of the Kuiper Belt. Analyzing more than 600 objects, they found that beyond about 50 astronomical units, the average plane was tipped roughly 8 degrees from where it belonged. They suggested a perturber around the mass of Mars near 60 astronomical units on a tilted orbit. The response was not dismissal. It was a specific, serious objection. Observational bias. We do not survey the sky evenly. If you find your objects in one strip of sky, those objects will share orbital geometry because of where you looked, not because of anything the solar system is doing. A measured tilt can be a portrait of your observing schedule rather than a portrait of the belt. That objection sat unresolved for 8 years. What Amir Siraj, Christopher Chiber, and Scott Tremaine built at Princeton was a way around it. A new method for measuring the mean plane, demonstrated to be independent of where the telescopes were pointed. They also stripped out every object locked in resonance with Neptune, because those have their planes set by Neptune and would contaminate the search. What remained was 154 objects, spanning 50 to 400 astronomical units. Then they measured. Between 50 and 80 astronomical units, the belt is flat. No anomaly. Between 200 and 400 astronomical units, flat again. No anomaly. Between 80 and 200 astronomical units, it is tipped by about 15 degrees. Sit with the shape of that result. This is not a gentle warp growing steadily with distance, which is what a single very distant, very massive object would produce. This is a distortion that switches on at a particular depth and switches off further out. It is confined. The team put the confidence at 96% for the inner band and 98% across the wider range, which means the odds this is a fluke of a small sample sit somewhere between 2 and 4%. Not nothing, and far short of what physics demands before calling something a discovery. This is not a discovery. It is a measurement the field takes seriously, made with a method built specifically to survive the objection that killed the last one. Amir Siraj put it about as carefully as it can be put. This paper, he said, is not a discovery of a planet. It is the discovery of a puzzle for which a planet is a likely solution. The next question is the one that turns the puzzle from interesting into unsettling. Not what made the tilt, what is keeping it. There is an obvious way out, and it is the first thing anyone reaching for a quiet explanation would grab. The early solar system was violent. Giant planets migrated across enormous distances, and passing stars came close enough to disturb the outer regions. Any of that could have kicked a section of the belt out of alignment 4 billion years ago, and what we see now would simply be an old bruise, meaningless in the present. The dynamics do not allow it. Orbits precess. An orbit does not stay fixed in space. It slowly rotates, wobbling like a spinning coin, losing speed, driven by the combined gravity of everything else in the system. And objects at different distances precess at different rates. That difference erases structure. Give a tilted population enough time, and the average plane settles flat. The way stirring erases a pattern in a cup of coffee. For the region in question, that takes less than about 100 million years. The solar system is roughly 4.5 billion years old. That is more than 45 opportunities to erase this tilt one after another. It is still there, which leaves one conclusion, and it is not subtle. The warp is not a scar left by something that passed through long ago. It is being actively maintained. Something is out there right now, holding the outer Kuiper Belt at an angle it does not want to sit at, and it has been doing so for longer than there have been complex animals on Earth. So the team asked the simulations what would be strong enough, close enough, and tilted enough to do that specific job. The answer came back narrower than anyone had a right to expect. An N-body simulation is brute force honesty. You place bodies in a model solar system, let gravity run, and see what it looks like after millions of years. Change the intruder's mass, its distance, its inclination. Run it again. Then compare each outcome against the one thing you actually measured, a 15-degree tilt that exists between 80 and 200 astronomical units and nowhere else. The mass has to fall between Mercury and Earth, a window that excludes everything above Earth and everything below Mercury. The semi-major axis has to sit between 100 and 200 astronomical units, and the orbit has to be tilted at least 10 degrees, because a body sitting flat in the plane cannot tip anything out of it. The authors are careful to note that values outside those ranges remain possible. This is a best fit, not a decree. But look at what the best fit describes. Not a gas giant, not an ice giant, not a failed star, or a distant black hole, or any of the exotic candidates that get attached to outer solar system mysteries. A mass between Mercury and Earth is a terrestrial world. Rock and metal and frozen volatiles. A solid surface you could in principle stand on. They gave it a name to keep it separate from the more famous hypothesis. They called it Planet Y. And the moment you accept that description, this stops being a story about a missing planet and becomes a story about a planet that has no business existing where it is. Before the problems, the place. Put yourself on the surface at 150 astronomical units. A crust of rock under ancient frozen nitrogen and methane, dark with the carbon-rich material that coats almost everything out there. Look for the sun first, because you will have to look. It is there. It is the brightest thing in the sky by a wide margin, and it is still recognizably the star that made you. But it is a point, not a disk, no wider than any other star, just fiercer. The light reaching your feet is roughly 1/22,000th of what falls on Earth at noon. It casts no warmth, it barely casts a shadow, and the sky behind it stays black in every direction, because there is no air to scatter anything into blue. The temperature is a few tens of degrees above absolute zero. At that temperature, nitrogen is not a gas, and methane is not a gas. They are rock. The ground under your boots includes things that on Earth we can only hold as air. Nothing moves. No wind, no weather, no erosion, no sound. Whatever this surface looked like when it arrived here, it looks like that still. And the year passes at a speed you cannot perceive. A body at that distance takes roughly 1,800 years to circle the sun once. If you had been standing here when the Roman Empire was intact, you would not yet have finished a single orbit. A dead world. Silent, frozen, unlit, and massive enough to reach across billions of kilometers and hold an entire population of icy bodies at an angle. At this point, almost everyone's mind goes to the same place, and it is the wrong place. In January of 2016, Konstantin Batygin and Michael Brown at Caltech published a hypothesis that has dominated public imagination ever since. A set of extreme objects far beyond Neptune had orbits that were clustered, pointing the same direction, tilted the same way, in a pattern random chance struggles to explain. Their proposed cause was a large unseen planet. The press called it Planet 9. The parameters have shifted as the search is tightened, from near 10 Earth masses at 700 astronomical units toward roughly 5 Earth masses at closer to 290. Searches through Pan-STARRS, the Zwicky Transient Facility, and combined survey archives have carved away large regions where it could hide. After 10 years, Planet 9 has not been found. Here is the important part. Planet 9, as described, cannot produce the warp. It solves a different puzzle. Clustering, not tilt. A body of that mass, that far out, produces a broad, smooth influence, not a distortion that appears at 80 astronomical units and vanishes again by 200. The Princeton authors state it directly. The body implied by the warp is distinct in both mass and semi-major axis from every version of the planet invoked to explain the clustering, which produces a conclusion most people skip past. These are not rival theories about one object. They are separate hypotheses about two objects. If both hold up, our solar system contains two planets we have never seen. Batygin himself, who was not involved in the work, called it an intriguing approach to probing the subtle warping of the outer solar system. Now the problem that makes this genuinely strange. Planets do not appear where they like. They condense out of a disk of gas and dust surrounding a young star, and that disk thins dramatically with distance. Close in, material is dense and orbits are fast. Far out, material is sparse and orbits are enormously slow, so a growing body sweeps up almost nothing per lap and has far fewer laps in which to do it. Standard formation models struggle badly to build a rocky world of Mercury to Earth mass at 100 to 200 astronomical units. There was not enough solid material and there was not enough time. The Sun's disk dispersed within about 10 million years. So if Planet Y is real, it almost certainly did not form where it is, which leaves two explanations, both hypotheses rather than established results, and both stranger than the missing planet itself. The first is exile. The body formed closer in, plausibly in the same crowded region that produced Mercury, Venus, Earth, and Mars. And during the era of giant planet migration, it had a close encounter with Jupiter or Saturn and was flung outward. Scattering of planetary embryos is a standard feature of every serious model of how the solar system settled down. Most scattered bodies are thrown out entirely. A small fraction end up on wide, steeply tilted, still-bound orbits. Under this story, Planet Y is a sibling of Earth, thrown into the dark. The second explanation does not involve our solar system at all. Rogue planets are real, and there are a staggering number of them. They are the natural waste product of planet formation everywhere. A young star system makes several planets. The planets interact. One gets ejected and drifts off with no star of its own, cooling toward the temperature of empty space. Population estimates for the Milky Way run into the hundreds of billions. The galaxy is not a collection of tidy solar systems. It is a collection of tidy solar systems moving through a fog of homeless worlds. Capture is possible. It is not easy. An object drifting past on an unbound path carries too much energy to simply fall into orbit. But in a young star cluster, where our Sun spent its first tens of millions of years, shoulder to shoulder with siblings, a third body can absorb the excess. Simulations suggest that if free-floating planets are roughly as common as stars, 3 to 6% of stars could end up with one. And here is the detail that makes this more than a curiosity. Captured planets do not settle into neat, flat, inner orbits. They characteristically end up far out, hundreds to thousands of astronomical units, on paths steeply tilted to their adopted system's plane. Tilted, which is precisely the condition the warp requires, and precisely the condition a planet born in our own flat disk would have had to acquire by violence. Both origins are speculative. Only a direct detection and compositional study could settle it. A captured world would carry the chemical signature of a different star's disk, isotope ratios matching nothing else orbiting the Sun. But that is the choice the evidence sets up. Either the Sun threw a rocky planet into the dark and it never came home, or the Sun reached out in its youth and took a world that belonged to someone else. We are not going to be arguing about this for another decade. High in the Chilean Andes, on Cerro Pachon, the Vera C. Rubin Observatory has opened its eyes. Its first images were released in June of 2025. It passed from construction into operations that October, and its landmark 10-year program, the Legacy Survey of Space and Time, is underway now. It is built almost exactly for this problem. An 8.4-meter mirror feeding the largest digital camera ever built for astronomy, 3,200 megapixels, imaging the entire visible southern sky every few nights for 10 years. It does not take a portrait of the sky, it takes a film of it, and a slow, faint object at the edge of the solar system is precisely the kind of thing that hides in a single photograph and cannot hide in a decade of them. Rubin will do two things. It will enlarge the catalogue of objects beyond Neptune until the warp is either confirmed or dissolved. 154 objects will become thousands. And if the planet exists, and if it is in the surveyed sky, and if it is not lost against the glare of the galaxy, Rubin may simply find it. Amir Siraj expects a clearer answer within 2 to 3 years. Samantha Lawler at the University of Regina, who remains skeptical of Planet 9, called this evidence promising. A smaller body out there, subtly warping the orbits. Think about what a confirmation would mean. Not a gas giant hiding in the far dark, which is the story we have been told for 10 years. A rocky world, somewhere between the mass of Mercury and the mass of Earth. Frozen, silent, unlit, and closer to us than Voyager 1. The spacecraft we launched in 1977, which this coming November becomes the first human-made object a full light day from home. We assumed the outer solar system was finished, a flat, complete, empty archive of what was left over after the real work was done. What the data says instead is that a specific band of it is being bent, continuously, by something with the mass of a planet, sitting closer than our furthest spacecraft. A world that either fell out of our own family or was never ours to begin with. We have counted the planets, we have taught the count to children, and we are still, in 2026, not certain we know the number. Thanks for watching, and I'll see you in the next one.